A very pleasant good morning to all. Today we are going to discuss translating relationship set with key constraints. This is being submitted by Group 4. The members of Group 4 are Adul, Atulya, Binula, Delna, Donna, Elizabeth and Githin. Now let's look on what is relationship set. A relationship it is an association between several entities. Several entities can have some common relationship or a connection between them. Such a connection is known as relationship. A set of a relationship is called relationship set. Always the relationship set is having relationship of same type. It can be a mathematical relation. Then key constraints. Primary key and foreign key. Primary key means they are used to identify each records in the value. The primary key is always having a unique value and cannot be null value. A table will be having a lot of records and each records are uniquely identified with the help of this primary key. In the given example, here roll number, name, address, age, all are the values and roll number is given as the primary key. This roll number is used to uniquely identify all other values like name, address, age, and next one is foreign key. Foreign key are the columns of table that point to the primary key of another table. This foreign key used to connect two tables. They act as a close reference between translating relationship set with key constraints. Translation is always approximate because it is not always possible to capture all the constraints in the ER design with relation schema. There are more than one approach to translate this ER diagram to relation schema. It is possible to make these translations complete and automatic. If an entity or relationship set involves n entity set and m of them are linked via arrows in the ER diagram, the key for any one of these m entity set constitute a key for the relation to which the relationship set is mapped. We can have m candidate key out of which one is designated as the key. This is an example. Here student is the entity, mn, name, age, email, all are the attributes and these attributes are linked to the entity student via a connection link that is arrow. This is the algorithm for that. Here create a table for entity set and each attribute in the entity can be set as a field for the table with appropriate type. Declare the field and the field comprising the primary key. And this is the SQL code. Mapping relationship set with key constraints. Here there are two entities, student and TOS, and directed by it is the relationship between these two entities. The relationship is always shown by a diamond symbol. Then algorithm. Create a table for the relationship set, add all the primary keys for the participating entity set as field, then add the field for each attribute of the relationship, declare a primary key using the key field from the source set entity set only, declare foreign key constraints for all the field from the source and target entity set. This is some SQL code. The captured key constraints is not the participation constraint. They require an alternative approach. Mapping relationship set with key constraints, it is the second approach. Create a table for the source and target entity as usual. Then add every primary key field as the target as the field in the source. Declare these fields as foreign keys. This is the SQL code for that. Here we have mentioned a foreign key also with that in the code, that is foreign key references of DOS. Mapping relationship set with key constraints and participation constraints. Algorithm create a table for the source and target entity set and add a primary key field for the target as the field in the source. Declare these fields as not null, then declare these fields as foreign keys. And this is the algorithm. This is another example. We can look once more the relationship of entity set with key constraints by this example. Here, employee and department both are the entities, and the field or attributes of employee are SSN, name, and load. Then managers is the relationship. Since it's the attribute of that, then department it's having attribute DID, D name, and budget. In the table, the managers has attribute SSN, D, and SIMS. Each department has at most one manager. No tuples can have same DID value but differ on the SSN value. A consequence of this observation is that DID is itself a key for the managers. The set DID and SSN is not a key. The manager's relationship can be defined using an SQL statement like this. The second approach is that translating a relationship set with key constraints, it is often superior because it avoids creating a distant table for creating relationship set. The idea is to include the information about the relationship set in the table corresponding to the entity set with the key, taking an advantage of the key constraint. In the manage example, because of department has at most one manager, we can add the key field of the employees tuple denoting manager and the since attribute to the department's tuple. This approach eliminates the need for separate managers relation, and queries asking for department's manager can be answered without combining the information from two relations. The only drawback to this approach is that space could be wasted if several departments have no managers. In this case, the added field would have to be filled with null values. The first translation avoids this inefficiency, but some important queries has to combine information from two relations, which can be a slow operation. The following statement defines the department-manager relationship and captures the information in both department and managers. Illustrates the second approach to the translating relationship set with key constraints. This is the SQL code for the second approach with managed table. Here the SSN can take null value. The idea can be extended to deal with relationship set involving more than two entity set. In general, if a relationship set involves n entity set and m of them are linked via arrows in the ER diagram, the relationship corresponding to any one of these m can be augmented to capture the relation. These are the references, and this is the conclusion of my seminar. Thank you.